I'm sitting here talking to you, Isabel, and I didn't have my mic on. As old as I am, that happens a lot. How are you today? All right, I just turned on the recording. Let's get going. I'm doing well, obviously not real well. I can't even remember to turn on the recording or the microphone. If you hear me screaming in a little bit, I'll be running into the house. It looks like it might rain out, but I'm still out on the deck because I like working outside instead of inside. All right, let's do a little bit of review from last week. Last week we were talking about finding derivatives, finding the slope at a given point. It says find the slope of f of x equals x squared plus 3 at f of 2. If I was going to do this problem using the work that we did last week, all I would do is I would use this formula, f of x minus f of a over x minus a, because that gives us the slope at any given point. If they give us a point here, and that point for this problem, and it's the limit as a approaches. So in this problem, it's 2. So f of x is just x squared plus 3 minus f of 2. Well, if I put 2 in here, 2 squared is 4 plus 3 is 7, all over minus 2 x squared. So that's going to give me x minus 4 over x minus 2 as 2 approaches. What am I doing wrong here? No, not f of a. It's 4, that's 7. Oh, that's x squared. Whew. That makes a huge difference there. All right, so then that becomes x minus 2, x plus 2 over x minus 2. And then the x minus 2 is a cross out. I'm left with x plus 2. This will give me the derivative at, or the slope at any given point. So if I put 2 in there, I end up with the slope is 4. Now today, we are going to learn what is called the power rule. And the power rule only works with polynomial functions. I mean, it doesn't work with trigonometric functions, log functions, exponential functions, stuff like that. But polynomial functions, it works really well with. So if I wanted to find the derivative here, the power rule says that, and this is, I think it's, you bring down, so if I had x squared, you bring down the power to the front of the variable, so that would give me 2x, and then you subtract 1 from this. So 2 minus 1 is 1. And then if it's a constant, the derivative of a constant is always 0. So the derivative for this function is just 2x. Now, what is the derivative? The derivative gives us the slope at any given point. So if I wanted the slope at 2, I just plug 2 in here. That gives me a slope of 4. Oh, that's exactly the same thing that I came up with. So the power rule is one of the rules that we're going to learn today, and it really helps us find the derivative really quickly of a lot of functions. So now, last week we also talked about finding the derivative of functions using the limit function. Okay, so if I'll do it the long way, and then I'll do it the real quick way. So it's the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so that means I have to plug x plus h in here, so that gives me x plus h squared plus 3 minus f of x, well, that's just x squared plus 3 all over h. And I'm not going to put that h in there because it's going to mess things up. So I'm going to just multiply this out. So that gives me x squared plus 2xh squared plus 3 minus x squared plus, oh, that's going to be minus 3 because that minus sign goes to both of these. So the 3's cross out, the x squareds cross out. I'm left with 2x h plus h squared all over h. I'm going to factor out an h on top, so that gives me 2x plus h over h crosses out. The limit as h approaches 0. Well, if that happens, that crosses out. So the limit, or the derivative, is just 2x. Now this is a derivative, which gives us a slope at any given point. Now I could have done that really quick with the power rule. The power rule says you just bring the exponent down, so that gives me 2x to the first, and then you subtract 1. And then any constant is just 0, so that's my derivative. How much quicker was it to do it this way than this way? So the power rule is going to be really cool this week, because then we can find the derivative of any polynomial function. But obviously you should know the long way, because then the power rule makes it much easier. It says find the tangent line to the graph of f of x equals x squared plus 2 at x equals 2. Okay, tangent line. What two pieces of information do I need? That's what I always write down. I need the point, and I need slope. So the point, well, they give me the x values, 2. So if I plug 2 in here, 2 squared is 4 plus 3, that's 7. So my point is 2, 7. And then the slope, well, we already said that the derivative of this function is just 2x. So if I want to know what the slope is of this function at x equals 2, I just plug 2 in here, and I get 4. So now I have a point, I have slope. Y minus 7 is equal to 4, x minus 2. Done. That's it. Pretty quick when you know the power rule to figure out tangent lines and the slope at any given point. All right. Before we go on, Isabel, is there any questions from last week that you did not understand? All right. Then this week we're going to be talking about the power rule. We're going to be talking about slope of derivatives at a point. And we're going to be talking about tangent and normal lines. Well, we already talked about tangent lines. We just have to figure out what a normal line is. The derivative of a function. The derivative of a function is basically an equation that gives us a slope at any given point. So if I gave you f of x, so if I gave you f of x squared, the derivative of that, this is how we write it, f prime of x, is just equal to 2x. This is the derivative. 2x is the derivative of x squared. And what does it give me? It gives me the slope at any given point to the original function. That's what a derivative does. It gives us a slope at any given point. Now, why is that important? Well, if you think about it, if you think about having a graph like this, and if you're dealing with businesses, you're dealing with maximum profits and minimum overhead and stuff like that. Well, where does a maximum profit occur? Well, it occurs when the tangent line has a slope of 0. And the minimum of a function is where the tangent line has a slope of 0. So we're going to be spending a lot of time trying to find max and mins of functions. Well, it's pretty easy to find a max or min out of a function. All you have to do is take the derivative, set it equal to 0, and that will tell you where there is a maximum or a minimum on that function. But that's not this week. That's just looking forward to why we're doing all this stuff with derivatives. All right, so this week we're going to find the derivative of a function using the constant rule. We're going to find the derivative of a function using the power rule. We're going to find the derivative of a function using the constant multiple rule. And we're going to find the derivative of a function using sum and difference rules. Okay, so there's going to be a lot of rules this week, but they're all really simple. The constant rule. We have used the limit definition to find derivatives. In this section, you will be introduced to several different rules that allow you to find the derivatives without the direct use of the limit definition. So here is a question for you. If I graph the equation, let's say I wanted to graph y is equal to 5. What does that graph look like? Y is equal to 5. What What does that graph look like? A straight line? Yeah, okay. It's equal to 5. How about a horizontal? Oh, there we go. A horizontal line that goes through 5, right? What is the slope of a horizontal line? 0. This is a constant. So if I gave you f of x is equal to 5, isn't that the same thing as saying y is equal to 5? They're basically the same. So if I ask you to find the derivative of 5, you better tell me that it's 0. The derivative of a constant is always 0. Why? Slope at any given point on that function. Well, the slope here is 0. 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 So doesn't it make sense that the derivative of a constant has to be 0? And that's our first rule, is that if you ever have a derivative of a constant, your derivative is 0. And that's all this says, is that the derivative of a constant is 0. So now, let me give you some really hard questions. I want you to find the derivative of all these problems. Well, y is equal to 7. That would be y prime equals 0. F of x equals 0. That means f prime of x equals 0. S of t is equal to negative 3. Well, that means s prime of t is equal to 0. The derivative of a constant is always 0. What is the derivative of this? If I asked you to find the derivative of f of x equals 10, what would you say the answer is? 0, right. The square root of 10 is just a number, right? It's a constant. You know, a lot of kids, they think it's a variable of some sort. It's not. It's a constant. It's just 0. All right, so there's one easy rule for this week. Now, the power rule. The power rule says, and this is the definition of the textbook, but basically what it's saying is if you have something like x to the 5th, you bring the 5 down, so the derivative of x to the 5th is 5x, and then you subtract 1, 5x to the 4th. What happens if there's a number in front? Say I had 3x to the 4th and I wanted the derivative. Same thing, just bring the number down. 4 times 3 is 12, so this would be 12x to the 3rd. Done. That is how easy it is to take a derivative using the power rule. Now let's say we had more than one term. Let's say I gave you f of x is equal to, let's go 3x squared plus 4x minus 5. What do you think the derivative of this function would be? Okay. And all you're going to do is you're just going to take the derivative of each term individually. So what would the derivative of that function be? (6x)? Disagree. Because there's a 1 here. So I agree the first term. So f prime of x is going to equal 6x plus, well, then I bring the 1 down. 1 times 4 is 4. And then x is just 1, anything to 0. So the derivative of 4x is 4. So that would be my derivative. Could you imagine using this function, the limit as h approaches 0 of f of x plus h minus f of x all over h? Could you imagine plugging x plus h into this thing? That would take a couple sheets of paper to finish all that math. But knowing the power rule, super easy. 6x plus 4. Way easier to use the power rule. All right, here are some problems. Now, I'm gonna stump you on some of these. I guarantee you. I want you to tell me what you think the derivative of each one of those is. The first one's easy, gets a little bit tougher, gets a little bit tougher. And you know, you can always, if you don't want to write that stuff down and you just want to tell me what the answers are, you can always use your mic. So what is the derivative of x to the third? Start with the first one. 3x squared. I agree. Okay, so let me get my marker out here. So f prime of x is equal to a 3x squared. How about g prime of x? 1/3 x to the negative 2/3. All right, now, if I was going to do this problem, first thing I would do is I would rewrite it as this, x to the 1/3, which I believe you must have done. So you bring the 1/3 down, so you get 1/3 x, subtract 1 from 1/3, and you end up with negative 2/3. Now, do not ever, ever, ever leave a negative exponent, okay? I don't like that. Now, the book sometimes does, but I don't. So I would say that my answer to this problem would be 1/3x to 2/3. Because remember, a negative exponent, you just bring it to the bottom, makes it a positive exponent. Okay, so does that, okay, so your answer to part C, I agree with, but I don't like it. I wouldn't mark it wrong, but I don't like it. Okay, I like what you did. You said y is equal to x to the negative second. So you brought the negative 2 down, so you negative 2x, subtract 1 here, you get negative 3. I like that, but that's a negative exponent. So why not just write it this way? Y prime is equal to negative 2x. Is that okay? So that's what I'd like to see. I would not mark it wrong if you had negative exponents. But I think it's much cleaner looking if everything is always kept with positive exponents. Okay, so I would like to see positive exponents all the time. All right, so that is the power rule. I mean, it's not that hard, is it? But you do need to know a little bit about math. You do need to know how to simplify radicals. You have to know how to change it to an exponent. You have to know how to, that this really is x to the negative second. So those are things that, you know, some kids don't know. They don't understand that kind of stuff, and that's where they'll really mess up using the power rule. All right, these are some problems off of Khan Academy. Fairly easy problems. If f of x equals x squared, f prime of x is equal to 2x. Dx just means what is the derivative of x to the third? So that's just going to be 3x squared. If y is equal to x to the fourth, what is dy dx? This is another way of just saying what is the derivative with respect to x of y? Well, it's 4x to the third. So really, once you understand the power rule, any polynomial function you should be able to come up with a derivative for. All right. Obviously, fractions cause more heartaches for some kids than others. I don't, you know, if I had x to the 3/2, I just bring it down. You got 3/2 x and then subtract 1 here, so that gives me 1/2. Not a big deal. Here, bring the 1/4 down, subtract 1, that gives me negative 3/4. Now, this is where I would rewrite this as 1/4 x to the 3/4. I don't like that negative exponent in there. Here I bring the 5/2 down, x, and then subtract 1. What does that leave me with? 3/2. And that's my answer. So, you know, doesn't matter if it's fractions for exponents, it still works the same way. You bring down the power, you subtract 1. That's it. That's the whole thing for the power rule. If they're negative exponents, same thing. Bring down the power, so that, oops, my marker's not on. So I got negative 1x to the negative second power. Bring the 12 down, negative 12x to the negative 13th power. Bring the 11 down, negative 11x to the negative 12th power. But again, negative exponents. All right, so I'm just going to rewrite it. Looks nicer. Negative 12 x to the, what was that, 13th? Looks nicer. Negative 11 x to the 12. So I would always ask you to put your exponents as positive. Makes it a little bit nicer to look at. All right. If the x bottom to start with, it's not a big deal. We just rewrite this as 1 over x to the 7th is the same thing as x to the negative 7th. 1 over x to the 10th would be x to the negative 10th. 1 over x to the 11th would be x to the negative 11th. Now, what if I gave you something like this? 3, 4, x to the negative 2nd. How would you rewrite that? So you can take the derivative, because you cannot take the derivative if the variable's in the denominator. Can't do it. So you have to get it up on top. Okay, so don't try to take the derivative when the variable's in the denominator. Can't do it. Three-fourths times x to the second. Okay, so I would rewrite it this way. 3x to the second over 4. So now if I want to take the derivative, multiply the 3. So that would give me 6x to the first over 4. Done. Okay. Any questions using the power rule? Or does it seem pretty easy? All right. Now, these are a little bit hard to read. Let me, so this one is, let me just write them down and you can work on them. So I've got the 4th root of x. I've got the 5th, or x to the 5th. And here I have the 5th root of x squared. Okay, so what I want you to do is I want you to tell me what the derivative of each one of those is going to be. And I'm going to turn off my mic and let you work for a little bit. See what Ah. Oh, Oli, wait. Oli, yep, Oli, get over here. Oli, get over here. Hey. Oh, I should have had my mic turned off there. Hate when those UPS people come up. The dog goes running. Okay. Give me gray hairs. All right, so those should be okay. Looks like you understand what you're doing. Let's take a look. Constant multiple rule just says that if there's a number in front, and just like we were working on before, oh, now I lost my marker here. That just says that if you have a 3x squared, this is the multiple rule. It just says you just multiply down here, so this would just give you 6x to the first. So doesn't make any difference if there's a constant in front, you just multiply the number, the power by it. Okay, sum and difference rules. All that says is if I give you a function like this, if I said f of x is equal to 3x to the fourth plus 5x to the third minus 2x squared plus 5, you wouldn't be able to take a derivative of this whole thing. But what the sum and difference rule says is that you can take the derivative of each individual term, and that will give you the derivative of the whole function. So this would just be 12x to the third plus 15x squared minus 4x plus 0. So this is the derivative of this function. Now, could you imagine taking the derivative like we learned last week of a function like that? That would take days to work out. But with the power rule, it's just a snap of the fingers, being able to find a derivative of everything that we're looking for. Okay, so those are all of the rules that we need to know in order to take derivatives using power. Now, realistically, this is probably one of the easiest rules. We have something that's called the chain rule. We have something that's called implicit differentiation. So there's a lot more to taking derivatives, but if it's just a normal polynomial, then we can use the power rule. Okay, and here's just, mosquitoes are starting to come out. Here's just a couple examples. Khan Academy, and they just work through the problems, so fairly easy to do. The last thing, all right, I'm going to stop on this problem. This is a great problem. Okay, here are two different problems from Khan Academy, and I think these are some pretty good problems. It asks you, it says h of x is equal to 2 f of x minus 3 g of x plus 5. Find h prime of 4. And this problem over here, it says that g of x is equal to negative 4 f of x plus g of x minus 2. Find g prime of 1. Okay, they look like they're really tough problems. But when you think about it, it's like, okay, so I need to take the derivative of h. Well, the derivative of h is just going to be 2 times f prime of x minus 3 g prime of x plus 5. Now they wanted me to find it at 4. So I'm just going to put 4 in there. 2f prime of 4 minus 3. When x is 4, f of x is equal to negative 4. When x is 4, g of x is equal to 13. F prime of 4 is equal to 0. So here I'm just going to go 2 times 0 minus 3 times 8. Oops, I almost made a mistake here. The derivative of 5 is 0. So that should be gone, right? Because if we take the derivative of 5, it's just 0. So my answer here is just negative 24. H prime of 4 should equal negative 24. All right, I am going to let you do this one and see if you can come up with the correct answer. That means I have to do the problem also. All right, so try it, see what you get for that answer. Ah. I've been saying that, man, my answer was way off from negative 54. I think I ended up with 12 for my answer. So what I did is I just took the derivative. I had negative 4, but if you take the derivative here, you just end up with f prime of x plus, if I take the derivative here, this is a constant, this is a number out in front, so I just leave it, g prime of x, and then the derivative of negative 2 is just 0. So then I want to find what f prime of 1 is and g prime of 1. So this is going to be negative 4 times f prime of 1. Well, f prime of 1 is 0 plus 3 times g prime of 1. Well, g prime of 1 is 4. So really, I'm just left with 0 plus 12, which I came up with 12. Ah, all right. That'll make a big difference. Okay. The last things for this week are normal and tangent lines. Okay. Uh-oh. Did I not? Okay, there it is. All right. Here's a problem. This is off an AP test, previous AP test. It says if f of x is equal to x to the fifth minus 2x squared plus 3 over x, find f prime of negative 1. Okay, so I'm going to let you try to figure that out. This is, as I said, this is a problem off an AP test. So let's see if you can figure out what f prime of negative 1. So basically what they're asking for is, what is the slope of this function at negative 1? And when you get your answer, just throw it in the chat box, and we'll see what the real answer is. Now, if I'm a betting person, because usually AP tests are basically the same thing. They'll put a positive and negative. So it's either going to be A or B or 2. No question. Well, positive 11 or because usually if they give you one answer, they'll give you the positive and negative of it. So it's not really, the only one that I would really cross off is D. I would almost bet that D is not a correct answer. I mean, I could be wrong. I haven't done the problem yet, but I would assume that it's not D. You're stuck with the last term. Oh, how about rewriting it like this? Anytime you have a variable in the denominator, you just make it, bring it to the numerator and just make it negative. Those little tricks on rewriting helps out immensely. Your answer is way off. All right, let's give it a shot. X to the fifth, that's going to be 5x to the fourth, minus now I've got 3x to the negative 1. Well, that's going to be negative 3x to the negative second. Well, again, I don't like a negative exponent, so I'm going to go 5x to the fourth minus 4x minus 3 over x squared. Okay, is that the derivative that you came up with? Okay, so now I'm going to put negative 1 in. I know that negative 1 to the fourth power is positive 1. Because negative times negative times negative times negative is positive, so this is just going to end up being 5 times 1. Minus, if I put negative in there, that's going to be a negative 4. Minus 3 over, well, negative 1 squared is 1. So I'm going to end up with 5 plus 4 minus 3. Holy cow, it's the answer that I said it would not be. I'm saying the answer is 6. They tricked me. All right. Do you see where you made your mistake? Because, okay, so, and usually they won't give you, because this is a non-calculator part of the test. So they would definitely give you, they're not going to give you a number like 7.8 to plug in here. It'll just be negative 1 or 1 or something like that. It'll be a very simple number to plug in, but they are checking to see if you understand how to take a derivative. You know, if you didn't know how to take a derivative of 3 over x, there's no way you're going to get this problem right. So it's a good problem. I would take a look at it again. All right, now we're going to find an equation of the tangent line and the normal line. All right. Do you know what a normal line is? What is a normal line? Okay. So if I'm going to try to find an equation of a tangent line and a normal line to this graph. Y is equal to x squared plus 4. Well, we know what that graph looks like. It starts up here at 4, over 1 up 1, over 1 up 3, over 1 up 5. And I would do the same thing on this side. Okay, so it's a parabola. This is what the parabola looks like. And I want to find an equation of a tangent line at x equals 2. Well, x equals 2 is, let me change my colors. X equals 2. Well, an equation of a tangent line, you need 2 pieces of information. You need a point, and you need slope. Okay, so what is my point, first of all? What is the point for this problem? Okay, so this point right here. 2, 6. Okay, now how did you come up with 6? You just looked at my graph, right? Well, my graph is not that great. I mean, if you think about it, it's right there. Why not just put 2 in here? 2 squared is 4. 4 plus 4 is 8. Always use the equation because my graph is not always great. So my point is 2, 8. Okay? What is my slope when x equals 2? Now, how do we find slope? We take the derivative. Derivative gives us the slope at any given point. So we plug the 2 back in. So what is my slope? That is my derivative. What is my slope? Because the slope is a number. 4 is correct. Yep, because that's why we find derivatives. We find derivatives so we can find the slope, so we can write an equation of a tangent line. Got the derivative, y prime is equal to 2x. This gives us the slope at any given point. So if I put 2 in here, because that's the one I want, that gives me a slope of 4. Now, let's say I asked you at 4. Well, shouldn't the slope be way higher? I mean, when you look at it, well, yeah, you put 4 in here, the slope is 8 now. So yeah, the slope keeps getting bigger the farther over I go on x. But this is my, so now I can write my equation. Y minus 8 is equal to 4 x minus 2. That's the equation of a tangent line. Now, what is a normal line? A normal line is a line that goes through the same point, but is perpendicular to the tangent line. Okay? So now I want to write an equation for this line. It goes through the same point, but it is perpendicular to the tangent line. Okay, so what 2 pieces of information do I need in order to write an equation of a normal line? I need a point. Well, the point is exactly the same thing, right? 2, 8. What's my slope? What is the slope of a tangent? What is the slope of a perpendicular line? Oh, very good. Opposite reciprocal. So my slope is negative 1/4. So now if I wanted to write an equation of the tangent line, y minus 8 is equal to negative 1/4 x minus 2. Boom. That is it. Yes, exactly. Exactly. Well, that is all I have for this week. Now you'll find the first 2 assessments this week are just finding derivatives. The second or the third one is finding, there's 4 questions on the second one or on the third one, and it's just asking you to find the normal line and the tangent line of equations. How do you find it? You need a point, slope. Point is very easy. You take whatever they're asking you, they give you an x value, you plug it into the function, it'll give you your y value. So that gives you your point. How do you find slope? You take the derivative. That gives you a function that will find the slope at any given point. So a fairly easy week this week. There's a lot of stuff that we went through. I will tell you that, you know, if you try to get through all this stuff in Khan Academy, it'll take you hours and hours. But in reality, it was pretty easy stuff, right? So that is it for this week. If you have any questions, bring them on. If not, we'll see you next week, same time, same place. All right. Bye.